So the number one failure point of a direct drive motor or a gear driven motor or any kind of motor is not the coils, not the gears, but the Hall sensors. So the question is, to sensor or not sensor? Meaning, some controllers can run sensorless. So that's an experiment I'm going to be doing next. Now, if you've never replaced a Hall sensor, these are Hall sensors. This is one single Hall sensor. Won't focus on it, but yeah. Hall sensor is nothing more than a transistor. Special type of transistor, but it's a transistor. So you can either replace them individually, or you can replace the entire circuit board. And they're not too difficult to change. So, well, I say they're not too difficult, but they kind of are, in a way. For one thing, the number one enemy to these transistors is heat. So, you can destroy a brand new Hall sensor very easily by initially just soldering it to the circuit board. Too much heat for too long, and this brand new Hall sensor will be destroyed. So you gotta be really quick with your soldering, or use a clip-on heat sink. They have little clip-on heat sinks that you can clip on the legs to try to offset some of that heat from going to the transistor. They're very, very sensitive. And like I said, that's the number one cause for failures in these motors, is high heat will knock a Hall sensor out quick, fast, in a hurry. So you want to try not to overheat them. And the number one cause for heat is high current and high voltage. So that is why a lot of guys, when they start using high output controllers, they use ferro fluid or stator aid, and that is probably one of the best ways to try to prolong your Hall sensors from burning up, is using some type of stator aid. Now, you may not have any problems with running your motors in high power during the wintertime, but in the summertime, when it's 90 plus degrees outside, is when you're going to discover these weaknesses. Now, if you don't know about ferro fluid or stator aid, there's plenty of videos on it. And ferro fluid is a magnetic liquid that a lot of people are using to help cool these motors, because you really can't submerge this entire motor in oil, although people have done it. But it really doesn't work too well. It puts too much resistance on the motor, and it's just not feasible. So by administering stator aid, and you don't need a whole lot, normally they drill a hole in the case somewhere in this area, and they just use a syringe and inject it inside the hub motor. And what happens is, from the motor spinning, it will put that fluid exactly where it needs to be. And where it needs to be is in between these magnets, well, in between the iron plates, the electric magnets, because this is an electric magnet. These aren't earth magnets here. The earth magnets are inside the hub casing, but these are electric magnets. But anyway, the ferrofluid needs to go in between these electric magnets and the earth magnets in your hub case. And it's only like a couple millimeters spacing, because normally there isn't a gap. There's an air gap in between these electric magnets and the earth magnets, and that keeps the heat from being able to transmit, across that air barrier. So when you put the ferrofluid in there, it creates a thin layer of liquid in between those two magnets, and helps transmit the heat from this side to the hub side, so it can cool the motor down. The outside of the motor is made of aluminum, so the aluminum can dissipate the heat. And if it's not being transmitted across that air gap, that heat is just staying inside the motor and causes things to overheat. So they use the ferrofluid to help bridge that gap. And then what they'll do is they put heat. Oops, dropped the camera. But they'll put heat sinks around the outside of the hub case. And I'm sure a lot of you have seen that, and that does work. However, the heat sinks alone don't do too much without the ferrofluid. You need that ferrofluid to bridge that air gap so the heat can actually transfer to the aluminum case. And when it transfers to the aluminum case, you can help release that heat by having the actual metal heat sinks that go around the perimeter of the casing. So I think that is a good solution to trying to prolong the life of your sensors, your hall sensors. And if you don't have stator aid or the heat sinks, that's something you need to think about doing, especially if you have a high output motor and a high output controller, and you're overvolting, or you're putting a lot of excessive current into your motor. Alright, so I want to do some experiments with running sensorless, meaning no hall sensors at all. But you have to first have a controller that's capable of running sensorless. And not all controllers can run sensorless. And a lot of controllers claim they can run sensorless, the cheaper brands, but they're not really good at doing so. Now, a high quality controller can run sensorless. Now, they all will run a little rough sensorless, but it's not something that's supposed to be negligible that makes running sensorless a bad option. Because when they say rough, it's normally with a little bit of the takeoff. When you first take off, it may stutter a little bit on the initial takeoff, but once the wheel is spinning, it's just like normal. And the fact that you can run wide open then and don't have to worry about burning up your hall sensors is a good thing. You won't find yourself stranded out there on a hot day. But anyway, I think I'm going to go with the stator aid or the ferro fluid and the heat sinks first, because I'm not going to be running an excessive amount of current. As I told you guys in the past, I don't like excessive current because excessive current does create a lot of heat. So there's two ways that you can increase your output as far as watts. And one of them is dumping a lot of current with the whatever voltage you're running at now. Say you're at 52, 60, or 72. You know, the way you're going to get more power is to have a controller that can output more current as far as phase amps. And at the same time, that's going to create a lot of heat. Now, there's another way you can increase your power output, and that's to increase your voltage. Because the formula for power is amps times volts equals watts. So, whichever one of those two variables you increase, you will be increasing the final output, which is the watts. However, mad scientists such as myself that often run balls to the walls increase them both. And yes, obviously increasing them both will increase your output. No doubt about that. But like I said, when you do that, you're running balls to the wall. So on that note, I prefer to increase my voltage and decrease my current and get the same result in watts. So yeah, let's say let me just give you a simple formula with small numbers. So let's say you're running 10 amps at 20 volts. It's going to give you 200 watts. Now, you can reach that same 200 watts by decreasing the amps. Let's say you cut the 10 amps in half to 5 amps. But then you would have to increase your voltage to 40. So 40 volts times 5 amps is still 200 watts. You've increased the voltage, but you decreased the amps, but you still have the same power output, but with using less current. Now, it's the current, the amps, that produce the excessive heat. Now, increasing voltage is not always a good thing either. Voltage is basically the force behind the electricity, and a lot of parts such as these transistors are subject to a specific voltage rating. So by overvolting, you can hurt sensitive components as well. However, if they're rated for, higher voltages, you stand a whole lot less chance of burning stuff up with lower current and higher voltage. I'm not going to dive too deep into that, why that's the case, but yeah, a lot of current flow is definitely a lot more harmful to electrical components than voltage. But don't get me wrong, voltage can destroy some things too. Now, that's why when it comes to the phase wires that provide which is basically the transmission line of current for your current, the flow from your controller to your motor. If you got little skinny phase wires like these hall wires, if those were your phase wires, they'd burn up. You can't have but so much current flow through little small wires like this. The thicker the wire, the more current flow you can have. And that's why sometimes the phase wires themselves is the only difference between, let's say, two motors, especially when you're talking about the cheap Chinese motors, the 1000 watt off-brand Chinese motor and the 3000 off-brand Chinese motor. Everything in that motor is completely the same. The amount of wraps on these coils, the diameter of wire that's in these coils, the hall sensors, everything is exactly the same. The only thing they change in a 3000 as opposed to the 1000 is the phase wires are heavier to allow more current flow. Now, sometimes on the premium motors, there'll be other differences, such as better quality hall sensors. Because like with everything else, they sell cheap hall sensors and they have the premium ones, such as these, depending on the branding. And, they're just better quality and can handle a little more abuse and are more in their tolerance range, they're not so far off of what they're rated to be. If something's designed at 20 ohms, a precision resistor would be 20 ohms. An off-brand cheap resistor may read 20.5 ohms or 21 ohms or 19 ohms. So, that's the difference in precision parts over generic parts. So that's basically it. So I'm just having this discussion because summertime is coming. It's getting hot, and you need to try to when dealing with electronics, you need to try to keep things running cool. Because when things start running hot, that's when they get out of their tolerance levels, like I was just mentioning, and then that changes up a whole lot of things. That's why stuff doesn't run as good. When transistors get hot and resistors get hot, their values change. And when values start changing, so does your performance. So you want to keep things running nice and cool. Now, for guys that have stock Onyx bikes, or any bike to be honest, and you have your controller mounted on the inside in an area where there's no airflow, where it can dissipate the heat, you're subject to your controller, you know, getting way too hot, and it may start hesitating on you, losing power, or start clipping when you put them high demands on it. So you want to keep your controller cool, and you want to keep your motor as cool as possible, and you want to try to keep your batteries cool as well. There's only so much you can do with your batteries though, but there are some things you can do. You can put a little fan on your battery case, maybe put a couple little holes in it and put a fan on it, or at least have your battery somewhere where air can actually be moving across it, because that's their biggest enemy, is heat as well. So like I said, I'm just mentioning these things because it's getting close to summertime, and a lot of you guys are going to start burning up your motors and controllers, and you need to know why that's happening, and you need to know some preventive measures you can take to stop that from happening. So, like I said in the beginning, stator aid and hub sinks help a whole lot. So go and Google that or YouTube that. Stator aid and hub sinks for your motors. Your controllers, put them on the outside where air can pass over them. And just try to keep your batteries as cool as possible. You don't want to be abusing your bike a whole lot when it's super, super hot. Alright guys, so that's it for today's discussion. Deuces. I'm out.